Hi, this is Kevin Trainer. Welcome to my tutorial for the um, Analyzed Expense Records program. So, what are we going to do in this uh, tutorial? Well, first of all, we're going to analyze some data. Okay, so I'm going to bring over two files that are going to be available to you in starter files. And one is called expense records.txt, and the other one is called test expense.txt. So, all right. And I'm working in a project here that is for my tutorial. And I already have quite a few programs in here. Um, Some of these are old from prior semesters, and some of these I'm just doing out of order, okay? But I do have a data subdirectory, and I'm going to bring over those files one at a time by doing a copy and a paste. And I already have an empty file.txt in there. That's going to help me. Okay. And okay, so here are my two files. I've pasted them in. Okay. All right. So let's look at expense records.txt. This is a, and you know what I'm going to do here? I'm going to change these two files just while I can. And I'm going to rename them from .txt to .csv. So I'm going to do a refactor, rename, and I'm going to make them .csv. And the reason I'm going to do that is that comma separated value files are a distinct genre of text files. Refactor, rename, put .csv. Okay, and it's pretty typical to use these kind of files to pass data around. Okay, and one kind of interesting thing about CSV files. Well, let's just look at their content. Usually the first line of a CSV file has a comma separated list of the column titles. So we can see that here the columns are date, expense, category, amount. Okay, and then in the second line we can see that the date is March the 15th, 2019. The expense category is meals and entertainment. And then the amount is $1,879.46. And we can see that on line 3, this is from October 1st of 2019. It's for fuel. It's for $17.69.80. And I don't want you to look at these data too closely for their realism because I generated the values randomly. Okay, but it's just a good file of data having to do with the expenses of some kind of enterprise. It could be a business. It could be some kind of not-for-profit. It could be a lot of things. Okay, and we've got these records of the expenses that they charged by category, by date. Okay, and I think they're from 2019, 2020, 2021, and 2022. And if we look down here, we'll see this. And there's a whole lot of them. I forget how many. There might be 20,000 lines. Yeah, there are 20,001 lines of data. Okay, and we want to analyze these. And what kind of output do we want to see? Well, I'm going to show you the output from a test that I've already run on my already baked version. Okay. And here's what it looks like. Okay. We process that file, expense records .txt. Okay. We printed a report title, a summary of meals and entertainment expenses for 2020. So it looks like in this particular program, we are only processing the expenses for 2020. We're only picking the meals and entertainment expenses, okay? And we're accumulating them by month, okay, by month number, 1 through 12, okay? And it looks like we spent somewhere between $47,000, that looks like the low value, and a little bit less than $75,000 is the high value. Okay, so we listed out what we accumulated for the 12 months, and then we calculated the mean. So we say the mean value was just a little over $60,000. And if you look at this, it's not too surprising that the mean would be a little bit over $60,000. And then we have, as is typical of the programs that we've been writing, we have a message that says how many lines we read from the input file and a helpful kind of count, how many qualifying expense records were found, and by that we mean how many were for the year 2020 and were for meals and entertainment. So you can see that over 20,000 records, less than 700 qualified to be accumulated, and here are the accumulated values. And these are all kind of centered around one value. The value that they are centered around is a little bit less than a little bit more than 60,000. And the reason that they are is I generated them randomly, okay? But in a typical business or any kind of enterprise, the values, from month to month would shift up and down, but they would shift up and down around some kind of central value. So this is this a lot for meals and entertainment expense? Yes, it is, but maybe we do a lot of that activity. Okay. Okay, so we've got the data that I've already showed you, and we're going to process, and we're going to have the results that I just showed you. What are we going to do in terms of pseudocode? Well, let me pull together some pseudocode. I didn't write this with pseudocode, and that's because it follows a kind of a pattern that I know well. Okay, but if I were to do pseudocode for this, I'd probably do the following thing. Okay, hang on, yeah. Okay, so what would I do first? Well, I've got to choose the file that I'm going to process. I don't always want to process the same file. So let's say we want to select the file. Okay. And then either, so in some way we want to choose a target year. choose a target year. And in the implementation that we're going to do here, we're just going to make that a constant in the program. That if the user wants to change it and run it again, if the program wants to do that, just fine. And then we need to choose a target expense category. Okay. Okay. And then we're going to want to open our file. Okay, and before that, we're probably going to want to set up some kind of accumulator list. Okay, and why do I say list? Well, the data structures that we're going to use, we're going to have to either pick between a list or a dictionary, and lists work really well when the kind of buckets that we want to accumulate things into are associated with a contiguous set of numbers. Like the contiguous set of numbers that we have are for the months. We have the months 1 through 12. We don't have to go searching a big list to find 1 through 12. We can just set up a list of 1 through 12. Whereas if you remember in the textbook, we were counting words. We weren't even sure what the words were going to be and how we're going to count them. It was really good to accumulate that in a dictionary. But this one is going to be in a list. And I think we're going to say for line in file, okay. Then we have to figure out if it qualifies, if it's the right year and the right expense category. So if line qualifies, remember, we have to worry about the first line. Okay, so we're going to say something like, if not first line, okay, and then we're going to say, if line qualifies, accumulate amount into the list, okay. That's pretty much all we have to do for that. And then we have to write the report, okay. Okay, so we're going to say something like for accumulator and list, print month number and accumulated amount. And then when we're done, we're going to do something like we're going to calculate the mean of the accumulated values, and we're going to print the mean, and then we're going to print the number of records, and we're going to print the number of qualifying records. Okay. Now, if I was, if the pseudocode was the deliverable here, I would probably adjust it and say, oh, I need to initialize my record count and my qualifying record count, and I need to add 1 to them in here and all that. But we're not going to solve that in the pseudocode. We'll solve it in the program. But for me, this follows a kind of general pattern of program. such that I don't write pseudocode for these anymore. I just write the code. Okay. Now, would I have written pseudocode for it? Would I have written pseudocode for it when I was a beginner? Yes, I think I would have. It would have looked something like that. Okay, so let's start the program. Okay, and new Python file. And I'm going to encourage you to type this in with me. Your assignment's going to be very similar to this one. So it's really going to be worthwhile for you to have learned this programming, and then you'll have the code to change for the assignment that you're going to hand in. Okay, so the new Python file is going to be called Analyze Expense Records. Okay, and we've got that. And I'm going to bring over some code. I'm not going to type it in. I'm just going to show it to you. So I've got a doc string, accumulated amounts from qualifying expense records by month, analyze monthly values. Okay, and this was from my solution, so I'm going to take that out of there. Okay, and now let's do a couple of things. One, it would be user friendly for us to include the code to prompt the user and ask for the year that they wanted to target, or the expense category that they wanted to target. Okay, since we're not really concentrating on this kind of user friendliness, we're just going to hard code these into the program as constants, with the idea that maybe this is the kind of program that we're writing for ourselves. Okay, we're a practitioner and we want to get the answers, and we're not going to give the program to a user. We're just going to give the answers to a client. Okay, and we're just going to hard code them here. And if we want to change them the next time we run it, then we'll change the program and we'll run it. It's not very user friendly in the absolute sense, but it's user friendly enough for us. Okay. Now we're going to define main. Okay. And I will bring over some code and I'm going to explain it. Okay. Okay. So I've got, I'm going to select the input file. Let me make this code a little bigger so you can read it. I'm going to select the input file. This program is going to be big enough that I don't want all that prompting and opening and all that kind of stuff in my main code. Okay. What is that code going to look like? Well, I'm going to copy that from my already coded version. Okay. And it's going to be the standard stuff that we do. Okay. So we're going to have a variable that has the data directory name, data. We're going to prompt the user for the in file file name. We're going to create a variable with the path and the file name, and then we're going to use that to open it for reading. And we're just going to return the file object, which we're calling infile here. And if you come back here, we've taken all that work and we've sort of reduced it to one line of code. Okay. The second thing that we're going to do is we're going to want to create a structure in which we're going to accumulate these expense amounts. And here's what we want to do. We want to create a list of 12 floats, each of which has been initialized to 0. And it turns out that the syntax that we're using here is a shorthand for creating exactly that. A list with 12 values in it, 12 items in the list, and they're all initialized to a float 0. We're going to be keeping a line count, initialize that to 0. Qualifying records, we're going to initialize that to 0 as well. Okay, so let's continue on. All right, so we have used the same name for the file object that we used in the lower level function. That's okay. They don't have to match, but it's okay if they match. So we're just saying for line and in file, and what's the, oh, I'm sorry. There we are. We had to push that over. Line count equals plus equal 1. So we bump up the line count. Okay. So let's look at the next couple of lines. Let's bring those over. So I'm going to bring this over, give myself a bunch of blank lines here. So why are we checking if the line count is greater than 1? Well, remember the first line in our file has got the column headings on it. Okay, so if we're reading a comma-separated value file, we want to eat record 1. Okay, so this is an easy way to do it. Okay, we count the lines as we read them, and then we don't process lines that are less than line 2. Okay, so let's get rid of that. Okay, so now we're going to process a line. All right, so for line and in file, we want to take the line, we want to split it, and again, this is a comma separated value file, so we want to split on commas. Okay, so if we split on commas, you can see we're going to get 3 values, a date in this ISO date format, a string that it describes the category, and an amount that's a float. Okay, so what have we done? Well, we do a split on the comma, okay, and then we unpack it. That's going to generate a list. We unpack it as date, category, amount as string, okay, and I always like, whenever I get something that particularly things like amounts and counts, and I've got the string version of them, I'd like to have a variable name that kind of warns that we haven't turned it into a proper internal number type yet. Okay? All right, so this is good. Now, let's look at the next bunch of code. I'm just going to bring it all over as a group, and then we'll talk our way through it. Okay? Okay, so we had a date, okay, but that's an ISO date. And we're interested in the parts of this ISO format date. We're interested in the year and the month in particular, right? So the first thing we have to do is we have to parse the date to pull out the parts. Okay. I decided I was going to write a function to do that. Okay. And I called it parse ISO date. Parse is kind of a computer sciencey kind of term, which means, work your way through the contents of a string and extract the parts that you want. That's what we call parsing. So we're going to pass in the date, and it looks like we're going to get back a year, a month, a day. And I know because I designed it that these are going to be ints. Okay. All right, so where's that code? Well, I've got it. Parse ISO date is pretty basic stuff. I'll bet that if we went to that datetime package that we talked about a couple of weeks ago, we probably would be able to find some code in that package to do that for us. But for me, at least right here, it was easier to write this code than to go searching for the code in there because, well, I spent a good half hour or more going through that package, and I don't remember seeing this exactly as direct code. I can think of about 3 things we could do to make it happen. But so we're getting in an ISO date, okay, and we do a split on the hyphens, okay, and that brings back year as string, month as string, day as string, and then I convert each of them into a proper int value using a call to int, okay, and then I return year, month, day. Now, what happens if I didn't have a proper int there? Well, it's just going to blow up, okay? Is that okay? We're expecting all the we're expecting all the values in the file to be valid. So if they're not and it blows up, well, we'll figure it out then, okay? So we're going to return year, month, day. So we call that, we get those back. So now I have to decide whether this is one of the expense records that I want to process. Okay, so I compare the year. If year equal target year, that was the year that we coded up in the constants, and category equal target category, well, then we do want to process it. So we're going to bump up the count of qualifying records, and now we're going to accumulate this into this list of floats. Okay. Now, the months are numbered 1 through 12. A list with 12 elements is numbered 0 through 11. Okay. So we can use the month number in an expression to come up with the index we're going to use. We have to subtract 1. Okay, so that means we'll be using the indexes 0 through 11. Okay, and we're just going to accumulate into it. We're going to say a plus equal, and then we're going to take that amount as string that we got back here, convert it to a float, okay, and then we're going to use it in the plus equal, and we're just going to add them up. Okay, do we need to do anything else for the lines that have records that don't qualify? No, we're just going to not act on them, and then it's going to go around the for in loop. We're going to have ignored them, Okay, they're not going to get accumulated, and that's going to be just fine. All right, that looks pretty good. So let's stop here and do a little bit of testing. Okay, we've gone a long way without testing, so this will be good. So what do we want to do? Well, we have this list that has the accumulated values in it. Let's just do this. We've done all the reading that we need to do, so let's close in file. Okay, and let's print those expense accumulators. Okay, and we'll see what they look like. Okay, and then we need 2 lines here and 2 lines there, and we still don't have a call to main. So let's get our call to main in there. Okay. Okay. Okay, that looks pretty good. Let's give it a run. So let's run this. And we have this file called expense records CSV. So let's do that. Expense records .csv. Okay, and look, we've got a bunch of values. Okay, now the first one seems to be 47,760, and the last one is 48,822. And if we go back and you look at that, report that I had, I think I'm going to have to run that again. I think those were the values. I'm not going to run that again. Okay. We're just going to. I think those are reasonable values. Okay. Now, how do we know they're reasonable values? Well, we don't really know that they're reasonable values. What we have here is we have a file with kind of live data in it. It's not really good for testing. Okay. So I tell you what I've done, and this is the kind of thing that I would want you to do, is I've taken this expense records file, okay, and I took a line or two of it, and I copy pasted a bunch of things here, and now I've got a file that's got it's got the following thing. It's got a bunch of records that should qualify. Okay, so here's what I did. I created a record that was from 2020. Okay, it was meals and entertainment, and it was $111.11. And then I created another one for this 2020 January, and it's $220.22. And so I've got those two amounts in every one of the months. Okay, so these are essentially 24 lines of data that I expect are going to qualify. And if I find all the records and I add them up, they're going to add up to $333.33. Okay. Now, so I need some qualifying data that I know what the answers are going to be. And then I need some data that would qualify except for it's the wrong category. So here's one where I took like all the records and I turned the categories to rent. Okay, so they should not qualify. Okay. And then the last thing I do is I think I copied the data. I think in each case, I took the group that I had created up top and I copy pasted and then I changed. So in the second time, I changed all the expense categories to rent. And then I copied them again and I left meals and entertainment in, but I changed the year to 2019. Okay. So of all of these, the only ones that should qualify are 2020 meals and entertainment. And then we know that the total for each of the months should be $333.33. Okay. It's very hard to test your code if you're not testing with data that you know the answers to. Okay. All right. So let's give this a run again. Okay. And this one is called test, not text, but test expense dot CSV. And there they are. 333.33. They're all right there. So I think our logic is working just fine. All right. Okay. Now the reporting is looking kind of crummy, right? All right. What are we going to do here? Let's close that out and go back and look at our code. So this is, we've got this initialization code, and now we have this accumulation code, and now we closed our file, and then we have a sort of a primitive version of the reporting code. Okay. Now this is already getting pretty long. You see, if you look at the main, it's already getting pretty long. I'm thinking if I'm going to have a loop that's going to print out things, it's going to be a little too big. So here's what I'm going to do. Okay, I'm going to put the reporting in a function. Print analysis report is going to be the name of the function. Okay, and you'll see that I'm passing expense accumulators here. And the reason is, okay, the function isn't going to be able to see expense accumulators unless I pass it. Okay, because expense accumulators is in main. Okay, and of course the code in the function is going to be inside the function. All right, so let's bring over that function. Okay, print analysis report, and let's see what it looks like. Okay, here it is. Okay, so a lot of times if I can, I will use a different formal parameter name than the actual parameter names. The actual parameter name is expense accumulators. Here, I think what I did is I refactored this. It was in the main, and when you refactor this, I did an extract method. When I did that, it kept the same names, but okay, they are the same. Okay, so what am I going to do? Well, I'm going to print a title for the report. And with F strings, we can include in the name of the report the name of the category, okay, and the number of the year. So it's going to say summary of the uppercase version of the target category name, expenses for, and then the year. So it's going to be really nice. Okay. I've got column headings for month and amount. Okay. And now I've got a tight little counted loop for I in range 12. Okay. That's going to count from 0 through 11. Okay. Well, that's good because our expense accumulators have those index numbers. Okay. And then I'm going to print the number of the month. Okay. In this F string. Uh, the first of the variables is I, but I have to increase it by 1 because we don't want month 0 through 11. We want month 1 through 12. Okay. And I said I wanted that to be right, justified, and 5 characters wide. And then I think I've got 4 spaces here, and I had 4 spaces up here. And then I want expense accumulators index I, and I wanted this to be right, justified, 12 wide, comma separators, and point 2f says um, 2 places to the right of the decimal point. Okay. And let's leave this last code off for now. Let's leave the mean out of here. Okay. And let's get this code to work. Okay, so if we run it again, instead of seeing that the print of the list, we should get a pretty report. All right, let's do that again. So let's say I want to print the report. So let's do the test one again. Test expense dot CSV. All right, that's looking pretty good. Okay, so the summary of meals and entertainment expenses for 2020. That's good. So we've got the number of the month, and then we've got the amount. And look, we've got exactly 333. I mean, 333 and 33 cents. So that looks good. Okay. Now, the version that I showed at the beginning, which I don't have an easy copy of to pull in, at the bottom of this, it had the mean. Okay. Well, of course, we know that the mean of all these 333.33s is going to be 333.33, but when we've got live data, it's going to give a useful number. So let's go back and take this code, and I'm going to show you guys a print analysis report right here. We've got so we're calculating the mean value, and we're using a function called mean, which it can't find. Okay. And so we're passing it the list, expense accumulators. This has got the 12 accumulated values, and we just ask for the mean, and it gives us the mean value back. Now, where could we find a wonderful function like this? Well, it turns out that there's a package called statistics. Okay, so this is the plain old Python statistics package. And it's got a whole bunch of these statistical functions which will work with floats. And it says these functions support int, float, decimal, and fraction. So it works with floats. That's what we have. Okay. And it works with lists. Okay, so we're going to have to import the one right up top, mean, okay, from statistics. Okay, and it turns out I already have an import from that on my already baked version. So let's bring that over. And it says from statistics, import mean. That's the function mean. Okay, and if we go back down to our code, well, mean doesn't have a red underline anymore because it knows where the function is coming from. So I calculated the mean using the mean function from the statistics package. I kept it in a variable called mean value, and then I used mean value in this print that says the mean value was, and I use mean value, a colon, and then the formatting is a comma for comma separators and a point to F to force it to print just at 2 digits to the right of the decimal. Now, could you have put this expression as, use it as the variable name in the F string? Yes, you could. It still would be good code. I just like to be a little bit clearer what's going on here, because one, I think that the code reads easily this way, and two, it reads especially easy for beginners. Okay, so we're going to calculate the mean. There's not going to be a lot of mystery about what the value will be. So this is test expense.csv. And not surprisingly, it says the mean value was 333.33. Okay, all right. Now, probably the hardest thing that we've done here so far is, if you look at the code, is just kind of the spacing of the columns on the report with the formatting characters and that kind of stuff, and of course finding the mean function in the statistical package. It's actually one that students have been finding. For years I had students calculating the mean by hand, and then they would go find this instead. And then I thought, well, I don't want people to calculate the mean by hand if they don't have to. And so now I've been won over by the students. Okay, now we had two more things that we printed out at the end. We had two kind of record count things. And I always like to show you this because I think it's a good programming practice. If you count the records as they go by, it makes it a lot easier to know that you got a good run. Okay, so let's take a look at that. So we're printing the line count lines were read from the input file, and then we're also counting qualifying records. So qualifying records, qualifying expense records were found. All right, so let's give all of that a test now. Okay, click off of the last line that we changed. Let's run it with the text expense dot CSV. Oh, I spelled something wrong. Yeah, I said text expense. Test expense CSV. And let's make that a little bigger. And this is great. So a summary of meals and entertainment expenses for 2020. All the months are accumulated to 333.33, which was more than one record. We had to find two. The mean value was 333.33. 73 lines were read from the input file. 24 qualifying expense records were found. That's what we're looking for. Okay. Now, what if we test this with the real data? Okay. The real data was called expense records.csv. So let's give this a run. Expense records.csv. And let's look at this one. Make it a little bigger. Okay, so just looking at the bottom, we read just over 20,000 lines, 674 qualifying records. Okay. And again, the low value is 47,000 and change. The high value is not quite 75,000. The mean value is just over 60,000. Now that's a useful number. So how did I come up with the idea for this? Well, when I used to run a business, every year we had to do the budget, right? And so we needed to forecast what our expenses were going to be month by month, right? And we used to do analyses like these in order to figure, we had a lot of seasonal expenses. So some things were like higher in certain parts of the year and that kind of stuff. And so, we would look, what were the expenses last year, month by month by month, and then we would do kind of a reasonability test, right? If in fact you're not worried about seasonal fluctuations, well, then your best guess would be, kind of the mean, and maybe we've had some inflation or we've got some more activity, so maybe you're going to take the mean and you're going to bump it up, right? But you're making the decision about the values you're going to use in your budget forecasting on the basis of real data. In this case, this is the data from 2020, but so we can imagine that we were doing the budgeting for 2021. Okay, so there you go. That's it for this one. Your assignment's going to be pretty similar, just a handful of changes. So I'll let you get on with that, and I'll say bye until next time. Bye-bye.